In the Netherlands there is a company called Beter Horen, and that literally translated means something like better hearing or hear better. And they sell hearing aids for elderly people, and these circuits, small units, cost approximately 1800 euros. So a lot of money. And I found that one elderly couldn't even use that hearing aid because it was too small. So my idea was to make such a hearing aid myself, and I searched on the internet and found a few circuits for microphones, spy microphones or so, and this part of the circuit here was from a circuit on the internet, and I found that it didn't work very well because there was no resistor here and a capacitor in the emitter lead, and that meant that it wasn't tuned to a good audio band. So I raised the value from the resistor here and bridged it with a capacitor, and now this unit here functions as a small audio amplifier. Here you see the circuit in real. Hope it's visible. I have to take the magnifying glass because after all was figured out, took me approximately 4 days, I mounted the whole circuit more or less in a miniature way inside this device. Works on 2 batteries, 3 volts, or on 2 nickel cadmium batteries, and they work on 2.4 volts. So this is how the whole thing looks like. Made a small LED here so you can see that it's on. And I mounted here this small earphone. And all was made very sturdy, with a sturdy piece of wire, the blue wire, because it's made for a real use in a real situation, and when someone tears on the wires they must not break. Okay, back to the circuit. I figured this circuit out during approximately 4 days. I've changed all the components here to try to get better results. All the capacitors were changed and to see how I could produce a sound with especially a focus on the audio part of the signal. So that's between, let's say, 500 Hz and 3 kHz or 4 kHz. And this capacitor here plays an important role. When you take this capacitor too big, you get more low frequencies. So I've tested it here with 220 nanofarad. I've used now 100 nanofarad. You can also use 50 nanofarad, but 100 works best. This is the condenser microphone, capacitor microphone. It's supplied with small voltage, 3 volts here or 2.4 volts. The whole circuit takes 27 milliampere. So the capacitor is supplied here with approximately 1.5 volt or so. The signal goes here into the first transistor. I've tested all kinds of transistors and found that a few transistors had a better low noise figure, and that were the BC183C or the BC237B, and I used the BC237B because of its somewhat better noise figure. You can also use BC547B. It depends. Here I've used a quite big coupling capacitor, but it doesn't matter because this capacitor here sets the whole frequency band from this small amplifier. There is some noise in the background, of course, and that's the reason is that there are so many transistors here. 5 transistors, and they all add a little bit noise to the circuit. This is a Darlington. This is an earphone from 30 ohms approximately, or 32, and that earphone has to have a good efficiency so that the speech is presented more clearly compared to the high and low frequencies, all to make the sound very intelligible, so that elder people can hear the people speak much better. The transistor connections, all the transistors have the same pin connections, emitter, base and collector. And as I've said, I've figured this circuit completely out. It's important to tell, for instance, that when you lower the value from this resistor here and from this resistor, the noise gets a little bit up. So this resistor must be as high as possible. I took 1 mega ohm and 470k. And here I took 76k. That was the best value in relation to the different transistors that I've used. And for instance, with other transistors, I had to raise the value from this resistor. Didn't do that, because otherwise the circuit started to oscillate. So this is a quite critical value in relation to the noise and the transistor that you use. There are special low noise transistors that have a lower noise figure compared to these two, but I've used this one, this transistor, because it has a high amplification, and that's also important. There is a relation between noise and high gain, so you need here a transistor with a high gain. So I think I've explained the circuit completely. Wish you luck. I hope it's visible now from this distance as a whole, the circuit. For one moment again, back to the circuit itself. Not so much to see because it's all very small, and it works quite good. I've tested it in a room where a lot of people were talking, and that's the real live test for these kinds of circuits.